Hello everybody, today we're going to be looking at problem 36, valid Sudoku. So in this problem, let's go over the problem very quickly. Determine if a 9 by 9 Sudoku is valid, only filled with cells that needs, only filled cells that needs to be validated according to the following rules. Each row must contain digits from 1 to 9 without repetition. Each column must contain digits from 1 to 9 without repetition. Each of the 9 3 by 3 subboxes of the grid must contain digits from 1 to 9 without repetition. The constraints, the notes that is given to us, that the Sudoku board that we're given can be valid but may not be solvable. Only the filled cells need to be validated. Okay. First, let me clarify, because LeetCode has two problems. One is called valid Sudoku. One is called Sudoku solver. We're not in the business of solving the Sudoku. We are just trying to validate whether the board is a valid Sudoku board or no. So for people who don't know much about Sudoku, the gist of Sudoku is very simple. We have a 9 by 9 grid where we have, of course, rows and columns, but we also have 3 by 3 subgrids. A Sudoku, the Sudoku board is a game where you try to fill this whole grid with numbers from 1 to 9, avoiding repetition of any numbers within the same row, column, or subgrid. So basically, if we have one here, the one that I'm pointing here at this position, we will not be able to have any ones in this row, neither in this column, nor in this square. Okay, so if we meet any number that breaks this rule, the board will not be valid. Again, we're not trying to solve it, we're just trying to validate it. So we're going to be given an input that looks something like this. It's going to be a character array that will have numbers and dots. Dot means an empty square, and we have the privilege in this problem to ignore empty spaces. Okay. Then so our real job becomes basically to check if there is any duplicates in one row, column, or subgrid. All right. So how to approach this problem? The first idea that can come to anybody's mind would be to do the brute force solution. I mean, if you've done advanced work, you may more advanced solutions and more efficient solutions may come to mind first. But this is the basic solution, where you basically say, okay, I'm going to be looking at the 3, so I'm going to scan the whole row, make sure that there's no 3. Scan the whole column, make sure that there's no 3s, and scan the whole grid, and make sure that there's no 3s in there. And yes, that solution will work, but of course it's not optimal, it's not efficient. So a better way to be to approach this problem would be to create a form of a data structure which holds a data structure for each row, column, and the subgrid, where it holds the numbers that it showed up before. Okay. All right, so we're going to be storing numbers that showed up before in a data structure. What data structure to use? Of course, if we're using an array, we're not really improving that much, because we're going to end up traversing every input there. So the better solution would be to use something like a hash set, because a hash set allows us to find whether an element is in there or no in a time complexity of 1, because it uses the hash code function to store data using a hash code. Okay, so let's go over this. We have in our problem 9 rows will correspond to 9 hash sets, 9 columns that will correspond to 9 hash sets, and 9 squares that correspond to 9 hash sets. Okay, so it seems to me like we need an array of hash sets. Finding rows and columns is fairly easy because if I'm at a position I, j, for example 0, 0, I know that I am in row 0, so this can correspond to hash sets in their hash set arrays to location 0 and column 0. It gets a little bit tricky when we're trying to get the square number, so we have to think of the squares like that. This is square 0, 1, 2, 3, 4, 5, 6, 7, and 8. So we realize that we have, depending on the row, so if I'm in row 0, 1, and 2, I'll be in location 0. If I'm in row 3, 4, and 5, I'll be in location 3. If I am in row 6, 7, and 8, I'll be in location 6. And then the column will determine the rest. So depending on the row, we will have an offset. So what I'm trying to do is find row, or let's call this I, whatever you want to call it. We need to divide it by 3, okay, and multiply it by 3, and that will give us the offset. So if you're in 0, 1, or 2, those are integers. 0 divided 3 is 0, 1 divided 3 as an integer, it's going to result into 0, 2 divided by 3 as an integer will result in 0. And when we multiply this in 3, we're going to have the offset is 3. 3 is going to be 1, 4 is going to be 1, 5 is going to be 1, so our offset is going to be 3, and 6, 7, and 8 will result in offset of 2. And when multiplied by 3, it's going to be 6. So that determines our offset. We need to determine, other than the offset, how much to add to them, and we're just going to be doing the same thing but with columns. So we're going to add to this number columns divided by 3. So if I'm in column 0, 1, 2, I'm going to be adding 1. If I'm in column 3, 4, and 5, I'm going to be adding 1 to my offset, and the rest is going to add 2. And that will give me the square number that I'm in. Using this number, I can go directly to the corresponding square hash set in the hash set array of squares, and check whether the number I have exists in this specific hash set or no. If it doesn't, I'm going to add it. If it is, I'm going to return false, which means that this is not a valid Sudoku board. If there's a little bit of confusion here, I hope that the code clears it out, but we're going to be going over the code right now. Okay. So the way we code this up is we need to first create our 3 hash set arrays. So I'm going to be creating a hash I'm going to store them in characters because I already given the data in characters. You can convert them to integers, but I don't see a need for that. Hash set characters. And this is going to be an array. Let's call this rows equal new hash set nine. We'll be copying this. This will be columns, and this will be squares. Avoid initializing, if you're doing this in Java, avoid initializing the doing initialization using the arrays.fill, because basically what that will do, it will fill all the arrays with one hash set. It will initialize only one object for all the hash sets. So avoid using arrays.fill. I'm going to show you how we're going to be doing this. Now we have an array of nulls at this point. So we're going to be traversing every square, of course, in the board. All right. Now we need to check if rows I equal null. We need to initialize it to a new rows I equal new hash set. And then we will need to check if rows I dot contains board I j return false, and then rows I dot add board I j. What that does over here is basically it checks if the rows is null. If it is, it's going to initialize a new hash set for the row. Then it will check if the row, of course, if we have a newly initialized, we're not going to have both of them to be true. But assuming this is false, for example, we're going to check if it contains the element that we're standing at, the hash set at this specific place. If it already contains it, we're going to return false because that means there's a duplicate. If not, if we made it here, we didn't return a duplicate, we're going to be adding it. And we're going to be doing the same for if calls j equal null, calls j not I equal new hash set if calls j dot contains board I and j, we would return false, and then we would calls j dot add board I j. Now it comes to finding the square and checking it. So we need first to calculate the square number using the formula we just talked about here. This one. So square number will be equal to I divided 3 times 3 plus j divided 3. And if squares square num equal null, squares should have picked a smaller name. That's fine. We did all of this and we never returned a false, then we will need to return true at the end. Let's run this code and hope that there is no... it seems to me like there's a logical bug somewhere. Calls j. If contains board ij, calls j contains rows, hash that. No, I've done something wrong. Okay, if rows I equal null, rows I no hash set. If rows dot contains board ij, return false. Rows I dot add board dot ij. If calls j equal null, calls j no hash set. If it contains a return false. Square num dot out dot print line square num zero zero and zero 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 zero. All right. Okay, I see where we're done. We forgot to check. Okay. We forgot to check, I mean, as I said earlier, we need to ignore empty spaces, and I forgot to do that. So we need to do if this logic needs to run only if board I j is not equal to dot, which means that it's not empty. That will screw up our code a little bit, but we will fix that. Okay. Okay, so let's do this to fix the indentation. And I mean, the good thing about it, you see it live. Okay, this example works. Let's see all the test examples that are given. That works. Let's submit it. Takes 7 seconds. Yeah, I have implemented it before using integer arrays. I'm not sure whether that will make it faster, but that solution will take basically O of n squared or O. I mean, since we're dealing actually at a fixed input, we can argue that it will always run at a fixed time. Worst case scenario, we have a 9 by 9 array. But yeah, let's assume that the input may vary. And in this case, we will have an O of n squared, where n is the width of the matrix. And you can say O of n, where n is the number of elements. So it's basically going to traverse over each element once, depending on how you look at it. Yeah, that's how to solve this problem. You saw we had a little hiccup with it, but we were able to proceed.